Okay, this is a problem that tells us to use logarithmic differentiation to find the derivative of this function y equals 3x plus 5 times 4x plus 9. Now, honestly, you probably don't have to use logarithmic differentiation for this problem. It might be just as easy to use the product rule or to simplify your function and then differentiate. Simplify, I mean, by expanding out the product. But I chose this problem at random, and let's just see how logarithmic differentiation goes, just for a reminder. Okay. So logarithmic differentiation says what we do is we take the natural log of our function. Okay, and the good thing about the natural log is that it takes this product and makes it a sum. So instead of having the natural log of a product of two factors, we have a sum of two different natural logs. That's just using the log rules. Then we can differentiate both sides. Okay. And on this side, let's see, if we use the chain rule, we'll get 1 over 3x plus 5 times the derivative of 3x plus 5, which is 3. And on the right-hand side, and for the second term, I mean, 1 over 4x plus 9 times the derivative of 4x plus 9, which is 4. Okay, but on the other hand, this derivative of the natural log of y, if you think about that, say using the chain rule, because we're differentiating with respect to x, right? We'll get 1 over y times y prime. Okay, so let me simplify the right-hand side. So if we want to know what y prime is, we can multiply through by y, right? Because the left-hand side is 1 over y times y prime. So if we want to solve for y prime, multiply both sides by y. And going back, the original y was 3x plus 5 times 4x plus 9. And then we'll have this multiplied by the whole thing. Okay, and now we're done. We could simplify this if we wanted. You may or may not have to. And in this example, it's pretty simple to check your answer, say by using the product rule. So I would recommend doing that when you can. But of course, there are other problems that you do with logarithmic differentiation where logarithmic differentiation is really maybe the best way to do it. That might be if you have a product with many factors, or a quotient with many factors, or some exponential things you also have to do with logarithms.